Hello, and welcome to the lesson PKI Implementation. You're watching the CompTIA Security Plus training course, and I'm your instructor, Lisa Spooner. We have already covered the terms and concepts of public key infrastructure. Now, let's look at the basics for PKI implementation. Because there is a long list of what PKI can do for us. We can utilize it to authenticate the identities of parties in a transaction, verify the integrity of messages, ensure the privacy of sensitive information, authorize access if digital certificates are being used as login credentials, and support non-repudiation. PKI keys can even be attached to smart cards. So in this lesson, we're going to look at publicly trusted certificate authorities versus internal certificate authorities. Also, working with registration authorities, key management, certificate management, and trust models. The trust models we're going to look at are hierarchical, bridge, mesh, and hybrid. The exam objective for this lesson is 6.4, which says implement PKI certificate management and associated components. Let's get started. When you are using a publicly trusted certificate authority, it means that a trusted third party issues and signs your digital certificate. When we say trusted third party, we mean that it's already trusted by web browsers and other applications. That means that you already have a copy of their cert and public key in the list of trusted certs in your browser. Kind of like I showed you for the certificate for trainsignal.com, except that copies of the certificates for certificate authorities are in the trusted root store in your browser. Sometimes TTPs will provide personal certificates for no cost. But SSL certs for websites come with a price tag, and some common commercial TTPs are VeriSign, GoDaddy, and DigiCert. If you have a public-facing website, you really do need a cert from a trusted third party. When customers visit websites with self-signed certs, they get warning messages and need to go through a number of steps to get their browsers to trust that website. This could be confusing or alarming. So the pros to choosing a TTP to issue your cert instead of creating your own is that browsers and other applications already trust them, like I said. And when you purchase an SSL certificate from them, your certificate will be trusted then as well. This works both ways. Browsers will automatically trust the SSL cert and will automatically untrust it when the time comes, like if your certificate becomes expired or sullied for some reason. Then the TTP will put your SSL cert on their publicly available certificate revocation list, and that information is spread to the different web browsers. Now the con is that as you start needing multiple certificates, the cost can quickly add up. If you want to set up digital certificates for every employee to use for internal email, you really should consider internal certificate authorities instead of paying for all those certs. Now the other option is setting up internal certificate authorities. This is used for intranets and other internal uses like hard drive and file encryption, digitally signing documents, authentication, and internal email. Pros are the lower cost and the greater flexibility and control. If you plan ahead, creating your own public key infrastructure can be scalable and secure. But this isn't easy. The big con is the intensive management overhead for key and certificate management and other considerations like configuring and troubleshooting support for the different protocols, systems, and applications that exist at your company, or deciding what trust model to use and its scalability, and working out interoperability with business partners. There are third-party options for creating your own CAs, but the ability to provide CAs and public key infrastructure services is included with server operating systems. Microsoft Certificate Services offers two options: standalone CAs and enterprise CAs. In the world of Windows, a standalone CA is not the same thing as a single CA trust model that we'll talk about a little later in the lesson. Instead, it refers to a CA structure that does not need Active Directory to function. So that means there still can be subordinate CAs. Again, we'll talk about that in a minute. On the other hand, enterprise CAs rely on Active Directory for its directory services. And enterprise CAs even have nifty templates that make creating certs easier. Using Active Directory allows certs to be linked to domain user accounts and allows the CRL to be published and disseminated using Active Directory. which is fine if your internal public key infrastructure is only used in-house and you don't need to publish your CRL publicly or for business partners, like a public trusted third-party CAs need to do. Depending on your needs, both kinds can exist within one organization. For example, you can have an internal enterprise hierarchy for internal users and a standalone system that is used for extranets and business partners that don't have accounts within your Active Directory or are using different directory services. Now let's talk about working with registration authorities. Remember, an RA is responsible for identification and authentication of certificate owners, but does not sign or issue certificates. And for the case of large internal CA hierarchies, they often function as a way to physically verify user credentials in person. So what happens when we have multiple locations for one company? Does a new employee need to drive across the country to show their ID and get their digital certificate? That's where the local registration authority comes in handy. As you can see, this new employee presents her credentials to the local registration authority who verifies them and sends the request to the remote CA to issue the cert. Next topic is some implementation considerations for key management. Key management needs to be incorporated into the security policy if you're going to set up your own certificate authorities. One thing to think about is key generation and signing. There can be centralized key generation where the keys are created and stored by the CA. This offers the ease of centralized management and the ability to back up keys. But backing up keys can be a security vulnerability in and of itself if it's not done securely. The alternative is decentralized key generation. Here, the key pair is created by the user and then submitted to the CA to sign. The CA does not keep a copy of the keys, so this allows the key owner to have the only copy. Whatever the method for key generation, it needs to be done in a secure manner, choosing a good algorithm and a long key size. And the private keys need to be distributed to the owners in a way that they are not lost or modified during distribution. Another point for key management is where and how the key repository will be maintained. Because remember, public keys and their certificates can be centrally located in a repository for ease of use. If you're using an enterprise Windows CA, then the repository is located within your LDAP directory. We also need to think about key recovery. And like with all the backup situations, we need to prepare this ahead of time so we aren't scrambling when something happens. Securely back up keys using key archiving tools. These can be configured to automatically back up your keys. Have a key recovery policy and assign users to be recovery agents. They will get special recovery agent certificates. In your policy, you want to specify what's called M of N control. We don't just want one person responsible for key recovery for two reasons. One, they could abuse this power. And two, what if they're unavailable? That's where M of N comes in. M, number of employees, out of N, number of recovery agents, needs to be involved in key recovery. This is separation of duties. An example? So if we make 5 employees recovery agents, we can configure it so that 3 of them need to be present to recover a lost private key. So that would be 3 out of 5, M out of N. When it comes to certificate management, we need to start with a discussion of policies and procedures. How certificates are created and handled needs to be in line with the organization's overall security policy. The security policy would let users know where they need to use PKI certificates and what the benefits are achieved by doing so. Starting here, there are 2 types of documents that need to be written by the IT department along with help from legal and HR. First is a certificate policy. A certificate policy focuses on certificates and the CA's responsibility regarding these certificates. It defines the intended purpose of the certs, the criteria and steps for certificate enrollment, issuing, usage, renewal, and archiving policies. And, perhaps most importantly, what a user must do if their keys are lost or compromised. The second type of document is called a Certificate Practice Statement, or CPS. These are derived directly from certificate policies and turn the policies into operational procedures, like the procedures or policies for issuing, renewing, and recovering certificates, or what algorithms are used and the key length requirement. Important note, if a PKI provider does not have these documents available, you should not use that provider. Let's look at the certificate and key life cycle. The first step is for a user to request a digital certificate that binds the public-private key pair to that user. A request is sent to the RA or directly to the CA if the RA doesn't exist. Some systems allow keys and certificates to be revalidated before they expire. In this case, a renewal request must be made prior to the existing certificate's expiration. In either case, the requester's identity is verified. If everything checks out, the next step is to issue the certificate. A key pair is generated using the algorithm and parameters spelled out in the certificate practice statements, and then the corresponding cert is created, signed, and sent to the requester. The creation can then be used by its owner, but only for the reason that it was issued for, until it expires or is revoked for some reason. If the private key is compromised, the owner is obligated to notify the CA, and this obligation may be written in the formal certificate practice statement. It's so important, I'm going to say it again. The user must notify the CA or RA immediately if a private key was lost or compromised. The expired, or if it's compromised, revoked, certificate is placed on the certificate revocation list. The CRL is published and the information is disseminated. Now, key destruction is permanently removing keys and certificates that are no longer needed. This is so they can't be used by attackers for impersonation. Hopefully, we are absolutely sure that the key isn't going to be needed to decrypt anything before we destroy it. Really, only the private key needs to be deleted. The public key is probably in a lot of different places and is useless without the private counterpart. In the world of PKI, trust is the concept of confidence in the certs that a CA signs. For an application or device to trust a certificate, the issuing certificate authority must also be trusted. Now, to know if this is true, that app or device looks at its list or store of trusted certs. If the CA is included, then we're good. Or even if we trust that CA's CA or further up the chain. PKI is very flexible and it can be implemented differently with different trust models. The simplest trust model is a single CA. This is a small PKI implementation with only one root certificate authority, and that root CA signs its own certificate. The hierarchical trust model is a top-down trust structure. The higher CAs sign the certificates of their subordinate CAs below them. If we look at this diagram, we can see a hierarchical or a tree, or what's sometimes called a distributed trust model. The root authority is meant to be the most trusted type of CA in an organization's PKI. Typically, both the physical security and the certificate policy of a root CA are the most rigorous than those for subordinate CAs. If the root CA is compromised or issues a certificate to an unauthorized entity, then any certificate-based security in your organization is suddenly vulnerable. A root CA can issue certs to users, but most often they only issue certs to subordinate CAs, who will then do the user or computer level cert issuing. So a subordinate CA is one that's had its cert issued by another CA at your organization. Subordinate CAs can also issue certs for more subordinate CAs. Also, say these two CAs here, they end up with a cross-certificate trust relationship. This guy trusts this guy and vice versa because they both trust the root CA that certified them. Certain subordinate CAs are called intermediate CAs if there are more subordinates under them. And when we start to get chains of CAs like this, the lowest ones can be referred to as leaf CAs. So these guys down here are both leaf CAs and subordinate CAs, and these here are both subordinate and intermediate. Now, like this one here, any of these leafs can actually be an RA instead of a CA. Another term you may hear is issuing CA. That is used to describe the CA that does the actual issuing of the certificates to the computers or users for email, for authentication, or for their smart cards. Another possibility is the mesh trust model. Here, two-way trusts happen between all the CAs, and that two-way trust is called a cross-certification. In the mesh model, each CA is both the root and the subordinate. So in this diagram, we can see a cross-certified mesh or what's sometimes called a network trust model. And this is also how peer-to-peer trusts work. Pairs of CAs establish cross-certification relationships, and this relationship gets its own cross-certificate. And for this to work, each user only needs to verify a single cross-certificate, and then all of the other certs from any of the other CAs can be trusted. This is fine for small organizations, but does not scale well to a large number of CAs. There's also the bridge trust model, where a cross-certification trust exists between two hierarchical PKIs. With the bridge model, one or more bridge CAs exist that set up that cross-certification relationship between the PKI implementations. This is great for establishing interoperability between organizations, like in an e-commerce B2B environment. That's business to business. And the last trust model we're going to talk about is a hybrid trust model. This is a mix of two or more different models for the most flexible structure. You need to be careful when planning a hybrid model because that flexibility can easily lead to chaos. And we've reached the key terms you should know section. For this lesson, I have 2 slides for you. The first page has some assorted new terms that we learned regarding PKI implementation. And the second is the different trust models that we discussed in this lesson. So, what did we cover in this short PKI implementation lesson? Well, we started with talking about publicly trusted certificate authorities. These will sell you certificates that are already trusted by web browsers and are vital for publicly facing websites. The alternative is setting up your own internal certificate authority. If you're going to set up your own PKI in-house, don't forget that the physical and network security of your root CA is very important. Working with registration authorities is an optional addition to PKI, and they're perfect for when in-person identification is needed before a certificate can be issued, even if that means that a local registration authority needs to be set up to send requests to a distant CA. Key management is an important part of PKI. We need to plan for the secure issuing, revoking, storing, and recovering of keys. And don't forget about M of N control. That needs M out of a possible N recovery agents present to recover a key. Certificate management is also important, and that's why all good public key infrastructures have certificate policies and certificate practice statements. There are a number of trust models possible for implementing PKI. Hierarchical is a top-down or tree-like structure. A bridge CA links 2 separate trusts. The mesh model creates a web or network of trust. And really, any or all different models can be combined to create a hybrid trust model. So that's it for this lesson on PKI implementation. Thanks for watching.